Have you ever tried to meet up with friends and you end up going back and forth in the group chat trying to figure out from their terrible description where you need to meet them? And then finally someone says, "Dude, just drop a pin." You get the link to their exact location in Google Maps and carry on with your day. As you may have already guessed, you used a geographic tool. In this video, we will cover the following tools: maps, the Global Positioning System, or GPS, Geographic Information Systems, or GIS, and remote sensing. We're going to spend a bit of time on maps, and then we'll be able to cover the other three pretty quickly. Maps are the most common tool that geographers use. It's kind of what we're known for. Maps are a visual and symbolic representation of space. Visual because we read them, and symbolic because we use lines and colors and icons to represent physical or social features. Maps can be used for finding a location or directions. These are called reference maps. Or they can be used for identifying or sharing a spatial pattern. These are called thematic maps. This map from the Skyline College website is one example of a reference map. These maps provide an overview of locations and features, and they're often focused on navigation, so getting around. Some other examples include road maps and topographic maps, which show hills and mountains. Thematic maps, on the other hand, illustrate spatial patterns, generally tied to a specific theme or topic. They use symbols, colors, and other elements to represent data. This map on the left is comparing the temperature of the ocean surface now with temperatures from the 1980s and 90s. In red, you can see parts of the ocean where the surface was warmer this month than in the past, and in blue, you can see parts of the ocean where the surface was colder this month. In addition to climate maps, other examples include population maps and election result maps with the red and blue states. Now that we've seen how different types of maps, so reference maps and thematic maps, are used to show us where things are or what's happening in specific locations, let's consider a fundamental problem that all maps face, representing a spherical round Earth as a flat surface. So what makes this map different from this map? We can see that the two images are actually showing spatial patterns differently, like ice coverage in white, or the relative size of Africa in the middle, and Greenland toward the top. It's not that I pasted them in my slideshow incorrectly. This is a result of something called a map projection, or a way of turning something spherical into something flat. The classic example in a geography class is an orange. When you try to peel an orange, even really carefully, you end up with pieces of the peel that either keep their curve or start to break apart. If you peeled apart a globe really carefully, you might get something like this. These are called gores, and they're actually how most globes are made. The map is printed like this, and then the strips are cut out and pasted onto a blank sphere. So projections are used because you can't flatten a globe without distortion or without breaks. There are a few elements that are traditionally included on a map. First is the scale, which tells us the size of the features on the map in relation to the size of the Earth. This is reflected by either a bar or a fraction. Here's an example where you can see at the top is a ratio or a fraction that reads scale 1 to 24,000. This means that 1 unit on the map equals 24,000 of that same unit on the Earth. So 1 inch on the map is 24,000 inches in real life, or a bit over 1/3 of a mile. Below that is a bar that shows the same thing, represented graphically. You compare it with a ruler and then measure on your map. Next is a north arrow, because up on a map does not always equal north. That's just something we've decided to do culturally. On the left here is an example of a basic north arrow, and then on the right is what's called a compass rose, showing all 4 directions: north, east, south, and west. The last traditional element is a legend or a key that tells you what the colors or symbols on the map mean. Here's an example from that sea surface temperature map a few slides back. The legend is important to include because it shows just how much warmer or colder the temperature is in terms of degrees Celsius. And here's the legend from the Skyline College map, showing a guide to the symbols used. Both are great examples of a legend for different map purposes. Sometimes maps don't include these traditional features, either because the map maker thinks they aren't necessary for their purpose, or because the map isn't meant to be an exact representation of space. Let's look at a few examples of maps that don't follow the tradition. Some maps are intended to be more artistic or to be figurative. They might not be to scale, or they might not show exact spatial relationships. Here's an example from the children's book, My Map Book by Sarah Finelli. This shows a map of a child's day, drawn from a child's perspective. It's a map because it's still a visual and symbolic representation of space. It has locations like school, home, and the playground, and it also has a pattern of movement between them. But it's definitely not to scale, judging by the giant toothbrush. The geographic content in this map comes from the way it represents a lived experience or a personal perspective. We can look at this map to understand what is important to a child who might have drawn this, though in reality the book was created by an adult. But these values still count as a type of data. Maps also don't need to be strictly on the page or on the screen or on a globe for that matter. Here are 2 examples of maps that represent space in a physical form in 3 dimensions. The first is a Marshall Islands stick chart. These were used back in the day by Micronesian sailors to represent and memorize ocean currents before going on a canoe trip. The sticks and intersections represent patterns of movement on the water, so that once the sailors were in the canoe, they would know how to get around by feeling their environment. The second example is a more recent invention. I don't know if we have any folks from the state of Michigan watching, but this is called the Michigan Hand Map. Apparently, because the state kind of looks like a mitten, folks from Michigan will hold up their hands to demonstrate to each other locations within the state. These maps demonstrate that humans are endlessly creative when it comes to representing space and place, and maps can take many forms. So far, we've covered the fundamental concepts of maps: reference and thematic, scale and legend, paper maps, and more physical maps. But as we saw with my opening example of finding our friends, a lot of modern geography happens on our phones and computers using digital tools. These digital maps and the tools used to make new paper maps too are made possible by a technology called the Global Positioning System, or GPS. GPS is a navigation system that uses satellites circling the Earth in outer space to pinpoint the user's location on the Earth. Your phone or other device connects to at least 4 satellites, and then the system does a math equation. Based on how long it takes your phone to receive a signal from each satellite, it can tell where you are in between them. The ground control segment in this diagram ensures the satellites are transmitting correctly. In addition to helping us get around, GPS is used in geography to ensure the accurate location of our data collected in the field. GPS shows us exactly where an observation was made, or near exactly, depending on the quality of our GPS device. Once we've pinpointed our data, we can then feed it into a computer system called GIS. Geographic Information Systems, or GIS, are another innovation on the map. GIS is a computer system that is designed for storing, analyzing, and visualizing geodata, any kind of information that is attached to a specific location. What's cool about GIS is that you can arrange data into layers that you can turn on or off. Since each spatial pattern or process gets its own layer, you can identify relationships between them when combined. GIS also provides a quick way to produce maps, which used to be drawn by hand, but now a computer can do it with much higher accuracy and a lot faster. Our last tool for this video is called remote sensing. This refers to any way of collecting data about a particular location, so geodata, without physically being there. So this might be satellite imagery or aerial imagery, so pictures taken from a plane or from drones. And remote sensing also includes a tool called LiDAR, which shoots lasers from a drone to measure distance. This picture on the right is an elevation model made using LiDAR. Light traveled a shorter distance to the mountains shown in red compared to longer distances to the flat land or water in blue, and it made this scan. In addition to measuring mountains, we can use remote sensing methods to do things like track deforestation, monitor Arctic sea ice, or map the damage caused by disasters. So to recap, geographers use maps for representation, GPS for location, GIS for analysis, and remote sensing for data collection. And these tools often work together. If we're physically in the field, we can use a GPS device to record the location of an observation. If we're not physically there, we can use remote sensing to capture data, and this relies on GPS also. All of that information, so geodata, can go into a GIS database for analysis and then to produce a map sharing our results. Now that we've gone over maps and a little bit about the tools that are used to make them, we can move on to your next forum post assignment. This is the first in a series of posts that my colleague Rachel Cunningham calls selfie field trips. Field trips are so important to geography class, but because this is an online asynchronous course, we use selfie field trips as a self-guided exercise to take the place of traditional field trips. You are not required to include a picture of yourself, but you are required to include some kind of picture according to the particular assignment prompt. So for our first selfie field trip, you will be taking a picture of a map to share with your peers. This can be one that you have physically seen. You can go out and take a picture of a map. That would be really cool. If you are not able to do so, you are welcome to find a map on the internet that you think is cool or useful. But make sure you include the source. Post the URL along with the map. You will answer a series of questions about the map, and then you'll respond to at least 2 of your classmates. There are more details in the forum, and I look forward to seeing what y'all post. Our next video will be in Module 2, starting next week. We'll be shifting from tools to physical geographic processes, talking more about the Earth as a system and its relationship with the Sun. Thanks for watching. See you next time.